Hello, dear learners. My name is Priscilla Janku. Please feel free to like this video and subscribe to this YouTube channel. Please also encouraged to email me at the address ftpriest@yahoo.ca if you're interested in a one-on-one online session. The theme of our discussion is entitled Unlocking Trigonometric Expression with Compound Angle Identities. So this presentation will illustrate how compound angle identities can be used to simplify trigonometric expression. Therefore, get ready to unlock the power of these identities. What are our learning objectives? By the end of this session, you should be able to learn how to simplify complex trigonometric expressions, how to use compound angle identities to achieve this goal. The second point of our discussion is actually to show you how to illustrate this. So we are going to understand a practical application on how to use compound angle identities to simplify a given trigonometric expression. So our practical illustration, we are going to consider a specific expression. We are going to see how to apply these compound angle identities. So here are a few steps you can follow. Firstly, you have to identify the compound angle. That is, you have to find the appropriate identity to apply. Next, you have to expand the expression that's given to you by substituting the compound angle identity. And lastly, you have to simplify this further. This consists of combining like terms to reach a simpler version of the expression. So a detailed breakdown of the solution is as follows. The first point would be to consider the initial expression you observe critically and see, secondly, what compound angle identity applies to that initial expression. Thirdly, you have to simplify by combining like terms and reducing it to a simpler form. And after simplification, you're going to get the desired final version of the trigonometric expression. Let's have a look at a specific problem so that you can see how we can use what we have studied so far, precisely how to use compound angle identity to simplify a given trigonometric expression. Our illustration will consist of solving the following question. We are required to prove the following identity: cosine of A plus B times cosine of A minus B equals to 1 minus sine squared of A minus sine squared of B. Next, we're going to determine the value of 1 minus sine squared of 75 degrees minus sine squared of 15 degrees without using a calculator. Let's have a look at the solution to this exercise. We are going to use the step that we've mentioned so far. So our initial expression is the following. This is the first step. Consider the initial expression, which is our left-hand side. So we're going to have cosine of A plus B times cosine of A minus B. We all know this trigonometric, this compound angle identity. So this is the same as cosine, according to from our previous knowledge, we have cosine of A times cosine of B minus sine of A times sine of B. The other expression is reduced to, or can be written as, cosine of A times cosine of B plus sine of A times sine of B. You see, this is more or less like the what we know as the difference of two squared, which states that if you have an expression A squared minus B squared, this is the same as A, this is equals to A minus B times A plus B. This little A is more or less like this cosine of A times cosine of B, and the little b is more or less like sine of A times sine of B. So this can be written as cosine of A times cosine of B all squared, okay, minus sine of A times sine of B all squared. We can apply the laws of indices to obtain cosine squared of A times cosine squared of B minus sine squared of A times sine squared of B. Here, we want to simplify this expression further. So how do we simplify this expression further? The goal here is to remember what is our destination. Our destination is to obtain 1 minus sine squared of A minus sine squared of B. This is our destination. So you look at your destination point and see what you can do to this expression to get to the final outcome. So you see that in this expression, we have sine squared of A, we have sine squared of B, so we can leave this. It implies that since in our final destination expression, there is no cosine. So this implies we have to use a well-known trigonometric identity to transform this cosine squared of A and cosine squared of B as an expression containing sine squared of A and sine squared of B. We all know that this is possible. So that being said, we're going to replace this by 1 minus sine. The reason why we decide to change cosine to sine is because in our destination expression, we do not have a cosine function there. So we need to replace cosine squared of A by our well-known trigonometric identity, which is equals to 1 minus sine squared of A. And same applies to cosine squared of B, which is the same as 1 minus sine squared of B. Is minus sine squared of A times what? Sine squared of B. So we're going to expand this. 1 times 1 gives us 1. 1 times minus sine squared of B is going to go for 1 minus sine squared of B. Minus sine squared of A times 1 gives us minus sine squared of A. And this time, this gives us plus sine squared of A times sine squared of B. Okay? Remember, in our original expression, we have a minus here. So we have minus sine squared of A times minus sine times sine squared of B. So you see, this cancels with this, and we are left with our final destination expression, which is 1 minus sine squared of A minus sine squared of B. End of proof. So we have used the various steps to show you how to reduce this complex trigonometric expression with the help of our well-known trigonometric compound angle identities to obtain a simpler version of this. Now let's answer part B of the question, which requires us to determine the value of. We want to determine the value of, this is part B. We want to determine the value of 1 minus sine squared of 75 degrees minus sine of 50, sine squared of 15 degrees. We want to simplify this expression without using a calculator. So how do we do this? We remember what we proved because we are asked to use the previous known proof to simplify this. So according to our previously known proof that we've done in our first step, this can be written as cosine of 75 degrees plus 15 degrees times cosine of 75 degrees minus 15 degrees. This is equal to cosine of 90 degrees times cosine of 60 degrees. So this is the same as, remember, our special angles. Cosine of 90 degrees is 0. This is 0 times cosine of 60 degrees, which is the square root of 3 over 2. And your final answer is 0. So this is how we can use a given trigonometric identity or compound angle identity to simplify a given expression without using a calculator. So what did we study throughout this presentation? We could observe the compound angle power. We could observe how identities simplify complex expressions. They can make equations much more easy. We discuss a step-by-step approach, how to break down solutions logically, how to follow each step without having to do with mistakes. So remember to practice because practice makes perfect. Once more, please like this video and subscribe to our YouTube channel. See you in our upcoming video. Thank you for listening to this video. Bye.